because of the fire or the oven or whatever. So the smell is incidental. The idea is that here you have an increase in pressure and air tends to move towards decreasing pressures when it goes to your room. That's why you end up having this smell when you go to bed. Okay. And with the patio, the idea is the same. The idea is that in the patio you have shadows of the same building, and the outside you have full sun. The moment you have different temperatures, the equation of ideal gas tells us that inside the pressure will be lower. So if the pressure is lower, air will enter your house. So you have cool air, you have air moving. That's enough to feel it fresh, even though it's the same temperature. Okay. So the patio and the when you fry fish, the smell in your room has the same cause. And there was something I wanted to tell you more, but I don't remember. Question of ideal gas, your room. I think that's it. I wanted to say something, but I don't remember. Okay. Well, the idea, the global circulation of Earth, global circulation means we consider full Earth like this. So the action is tilted, but that's matter. The idea is that you get more energy in the equator than in the more energy, because the incidence is direct, not it's like giving you a full punch or a punch which is tilted. That's the idea. Okay, because here when you have the sun rays coming, you get higher energy, so higher temperature in the equator than in lower intermediate latitudes or very high latitudes. So here we have less temperature because we have less energy. So the idea is the same as before. There are convection flows that go Hadley cell, and then there's another one, I'm not sure, I think it's ferret cell. Yeah, one that goes from the equator to how do you say, intermediate latitudes. There's over the web, but that's the idea. And then there's another from the intermediate latitudes to the polar. Hadley cells and the ferret cells. Don't be confused by the nomenclature. These are air currents that tend to homogenize using the equation of the ideal gas, because even though the atmospheric gas is not ideal, it's very similar because the pressure is not that big. 1 atmosphere, less than 1 atmosphere, 1 point something atmosphere, no, not even that. So it's not like an ideal gas. So it's amazing that only how one simple equation can explain so many phenomena. That's the beauty of physics. To be able to understand, identify the physical quantities that are able to explain the phenomenon, understand the relationship between them, and being able to explain so many phenomena like the air currents when you open a window, I remember what I was going to say. The air currents when you open or the air currents in a patio, or the air currents in the global circulation. Global circulation means these air currents at a planetary scale. This window stuff is the solution for when you fry fish or you use garlic. The solution is pretty simple. You close the door of your room, of your bedroom. You close the door of the kitchen, and then you open the window of the kitchen if you have one. So usually the heat will be higher than the outside, and air will go to out of the house instead of going to your room. Okay, very nice the ideal gas equation, and very nice that is able to explain so many things. Ideal gas equation. Also also able to explain the breeze. The breeze is the same idea, the breeze. The earth and the water and the sea are at different temperatures, so you have the breeze. Okay, good night, that's enough. Bye.